Hello, welcome to Astronautics for Exploit. This is Dr. Ayeshola Ogundele. Space gas stations, the necessity and design strategies. Humanity's audacious ambition to have unhindered in-space transportation. The focus points are as follows. Space gas stations, the necessity of space gas stations, Earth and space storable propellant and depot fuels, and space gas stations design strategies. Humanity's audacious ambition to live and work in space and dig deeper into the cosmos is hinged on ability to have unhindered in-space transportation. Having gas stations positioned in space will help to prolong the lives of satellites without fuel and ultimately lead to high return on investment. The future desire of humanity to send humans to the moon and to engage in mass-band crewed spacecraft from the moon or near the moon will become much easier and affordable with the establishment of space gas stations in Earth's orbit, Moon's orbit, or on the lunar surface. Spacecraft servicing gas stations depots located on celestial bodies or interplanetary space will help to extend the lifetime of spacecraft that have nearly consumed their orbital maneuvering fuel. Examples are spacecraft placed in a geosynchronous orbit. Several space gas stations and propellant depot design strategies have been put forward for in-space refueling. The design strategies include propellant settling and transfer, propellant usage for altitude control and reboost, the maturity of the refrigeration equipment or cryo coolers, and the power and mass required for reduced or zero boil-off depots with refrigeration. Space gas stations. A space gas station or space propellant depot is a gas station positioned in space or a celestial body or interplanetary space for refueling spacecraft or space stations. Several proposals of space gas stations have been put forward by the researchers, government space agencies, and private space companies. Illustration of orbit-far space gas station concept is shown in this picture. Several celestial and interplanetary gas stations depot concepts exist depending on the type of fuel to be supplied, location, or type of depot, which may include a propellant tanker that delivers a single load to a spacecraft at a specified orbital location and then departs. In-space fuel depots might be located near or at a space station. Potential uses of in-orbit refueling and storage facilities include space agencies, defense ministries, and communication satellite or other commercial companies. Artist's impression of Think Orbital platform for in-orbit fuel depot is shown in this picture. Various places for locating space gas stations have been proposed. A depot is proposed to be placed at the Earth's orbit, at Moon Lagrange Point 1, or behind the Moon at EML2 to reduce cost to travel to the Moon, Mars, or Mars orbit. On Starship's third integrated flight, propellant transfer in orbit was demonstrated. This capability is required by the Artemis 3 mission, which will attempt to land the crew on the Moon with the Starship vehicle. Concepts for future orbiting fuel stations is shown in this picture. The necessity of space gas stations. Spacecraft servicing gas stations depots located on celestial bodies or interplanetary space will help to extend the lifetime of spacecraft that have nearly consumed their orbital maneuvering fuel. Examples are spacecraft placed in a geosynchronous orbit. The spacecraft will conduct a space rendezvous with the depot, or vice versa, and then transfer propellant to be used for subsequent orbital maneuvers. Image of how solar power might be created on the Moon to power a space gas station is shown in this picture. Since all or a fraction of the transfer stage propellant can be offloaded, the separately launched spacecraft with payload and or crew could have a larger mass or use a smaller launch vehicle. With a low Earth orbit depot or tanker fuel, the size of the launch vehicle can be reduced and the flight rate increased, or with a newer mission architecture, where the Beyond Earth Orbit spacecraft also serves as the second stage, can facilitate much larger payloads, which may reduce the total launch cost. Illustration of orbit far fuel depot tankers and other infrastructure needed for in-space refueling is shown in this picture. Using space gas stations to refuel spacecraft in orbit is very advantageous. This is attributed to a large portion of a rocket being propellant at time of launch. Launching an unfueled spacecraft will require less structural mass, or the depot tanker itself could serve as the second stage on launch when it is reusable. Orbit fab refuel satellite is shown in this picture. An on-orbit market for refueling may be created where competition to deliver propellant for the lowest price takes place, and it may also enable an economy of scale by permitting existing rockets to fly more often to refuel the depot. This also establishes the need for space gas stations. If used in conjunction with a mining facility on the moon, water or propellant could be exported back to the depot, further reducing the cost of propellant. Illustration of orbit fab market-driven fuel logistic network is shown in this picture. An exploration program based on a depot architecture could be less expensive and more capable, not needing a specific rocket or a heavy lift to support multiple destinations, such as the moon, Lagrange Point, asteroids, and Mars. If used in conjunction with a mining facility on the moon, water or propellant could be exported back to the depot. Illustration of astroscale in-space refueling services is shown in this picture. Earth and space storable propellants and depot fuels. In general, rockets and space vehicles propellant usually take up to two-thirds or more of their total mass. Large upper-stage rocket engines use a cryogenic fuel like liquid hydrogen and liquid oxygen as an oxidizer because of the large specific impulse possible. Sample rendering of Cislunar Tech extracting lunar resources to produce rocket propellant is shown in this picture. Lunar and Mars missions will require weeks to months to accumulate tens of thousands to hundreds of thousands of kilograms of propellant, so additional equipment may be required on the transport stage or the depot to mitigate boil-off. Illustration of space propellant depot is shown in this picture. Non-cryogenic earth-storable liquid rocket propellants, including RP-1 kerosene, hydrazine, and nitrogen tetroxide, and mid-length cryogenic space-storable propellants like liquid methane and liquid oxygen can be kept in liquid form with less boil-off than the cryogenic force. Gaseous or supercritical propellants, such as those used by ion thrusters, include xenon, argon, and bismuth. Illustration of SpaceX in-orbit refueling is shown in this picture. Space gas stations design strategies. Various strategies have been designed for the implementation of space gas stations. Several space gas station and propellant depots design strategies have been put forward for in-space refueling. The design strategies include propellant settling and transfer, propellant usage for altitude control and repose, the maturity of the registration and cryocoolers. Canada's robot performing satellite refueling is shown in this picture. Transfer of liquid propellants in microgravity is complicated by the uncertain distribution of liquid and gases within a tank. Propellant settling at an in-space depot is thus more challenging than in even a slight gravity fade. ULA plans to use mission to fly test centrifugal propellant settling as a cryogenic fuel management technique. Testing of new technologies for robotic refueling is shown in this picture. In the absence of gravity, propellant transfer is difficult since liquids can float away from the inlet. As part of the Orbital Express mission in 2007, hydrazine propellant was successfully transferred between two single-purpose design technology demonstration spacecraft. The Boeing Servicing Spacecraft transferred propellant to the Ball Aerospace Serviceable Clean Spacecraft, NESSAT. Since no crew were present on either spacecraft, this was reported as the first autonomous spacecraft-to-spacecraft flow transfer. Northrop Grumman's orbital refueling is shown in this picture. Various design strategies are underway to transfer propellant and refill space gas stations and depot tanks. Organizing the construction and launch of the tanking rockets bearing the new fuel is the responsibility of the propellant depot's operator. By using separate rockets, the tankers can be smaller than the depot and larger than the spacecraft they are intended to resupply. Illustration of first lunar base and gas station in space is shown in this picture. Design strategies for the transfer of propellant between a low Earth orbit depot reachable by rocket from Earth and the possible deep space depots such as the Lagrange points and Phobos depots could be performed using solar electric propulsion tugs, and they are under development. Several missions are currently under development or proposed to support propellant depot revealing. The picture here shows concept Manchester Space Force Station. For more information, contact Astronautics for Exploits. You've been listening to Space Gas Station, the necessity and design strategies, humanity's audacious ambition to have unhindered in-space transportation, presented by Dr. Ayoshola Ogundele, with the focus point space gas stations, the necessity of space gas stations, Earth and space storable propellants and depot fuels, and space gas stations design strategies. Thank you.